Good morning, welcome to class. Let's start by please downloading the notes for 3.4. And on the first slide of the notes, there is an equation that it asks you to graph. Your grades for quiz 3.1 to 3.3 should have been posted by now, and if you get finished with that, you can also look at those, or you can do that after class today. So go ahead and download the notes and work on the first slide, which asks you to graph this equation. Pause now until you're finished. Alright, so hopefully when you graph this, you remember what we've learned about graphing by making a table of values. We start by plugging in numbers for x, getting values for y, and plotting those points. So first, if we start, we've got -1 we're going to plug in. That gives us, y equals -2, or 2 times -1 is -2, minus 3 is -5. Then we plug in 0, we get y equals 2 times 0 is 0, minus 3 is -3. We plug in 1, we get y equals 2 times 1, which is 2, minus 3 is -1. And if we plug in 2, we get y equals 2 times 2, which is 4, 4 minus 3 is 1. And I put another number in there, let's plug in 3 since we've got it up there. 2 times 3 is 6, 6 minus 3 is 3. So you should have came up with all these points. -1, -5 means we go left 1 and down 5. 0, -3 is down 3. 1, -1 is right 1 and down 1. 2, 1 is right 2 up 1. And 3, 3 is right 3 up 3. And then we draw the line that goes through all those points. Hopefully hitting all of them to the best of our ability. It should look like this. And put arrows at the ends. Again, make sure your lines go all the way to the edge of the graph paper, and we put arrows at the ends. So this should have been a review from you from what we were doing earlier in the chapter in which you were just quizzed on. So moving on, let's take a look at the next slide. There are 2 different types of graphs that you can draw. Now the first one, it doesn't give you an equation, so there's no numbers I can plug in for x or anything like that. But we did learn another method of graphing, which is by finding the intercepts. And here they tell you to graph a line that has an x-intercept of -3 and a y-intercept of 5. Well, an x-intercept of -3 is just 3 to the left of the origin. A y-intercept of 5 is up 5 on the origin. And then we draw the line that goes through those. And put our arrows at the ends. So again, another method we learned was by finding the intercepts. But today we're going to talk about another method of graphing, which is actually going to be much easier than most of the other methods. So for this one, before we get into that method, let's see if you could graph a line without any intercepts, without knowing anything about an equation for a line. What if I asked you to graph a line that goes through the point -3, 1 and has a slope of -3/4? Well, we can start with the one point that we do know. We know it goes through -3, 1. So left 3, up 1, there's a point on our graph. And then it says it has a slope of -3/4. So let me rewrite that slope as -3 over +4. So a negative slope, anything that's a fraction that's negative means it's a negative divided by a positive, or you could think of it as a +3 over -4. We would rarely write it that way, almost never. But I'm going to write it there for just a second. Also keep in mind what we learned about slope. The definition of slope is that slope is rise over run. So if we think of slope as being a rise over run, our numerator is our rise, which means our vertical change up and down. Well, if we have a rise that is -3, that means it goes down 3. And if the run is +4, that means we go to the right 4. Again, remember for a vertical line, up is positive, down is negative. For a horizontal line, left is negative and right is positive. So a rise of -3/4 means I can go down 3 and right 4. So I'm going to start at that point that we had already, -3, 1. And from this point, I'm going to count and go down 3, right 4, and put another dot. And I can keep going, down 3, right 4, put another dot. down 3, right 4, put another dot. And I can create as many dots as I need to. Oops, did I go over far enough? Nope, should be over one more, sorry. I can create as many points as I need to, and the object is to get as close to the edge of the paper as I can. So I'm pretty close to the edge of the paper here. Remember, I also said that a negative slope could also be written as a positive over a negative. A positive divided by a negative is also a negative. So thinking of rise over run, a rise of positive 3 means I could go up 3, and a run of negative 4 means that I wouldn't go right, but I would go left 4. So I could also have started at that point negative 3, 1, and I could have gone up 3, but left 4, and put a dot. Notice that point is still on that same line. That point is still continuing that other line. And if I could try to keep going, up 3, left 4, it would take me off the screen. So I want to get as close to the edge of the screen as I can, and then when I go to draw my line, what I'm going to do is I'm going to put my pen right on one of the points that's close to the edge of the page, and I'm going to extend it through the last point on the other edge, and it should hit all the points in between. Draw your line. So if you know a point on a line and you know the slope, you can quickly create that line by just starting at the given point and just counting off your slope as a rise over run. Down 3, right 4, or up 3, left 4. And that's going to be really important for what we're going to talk about today, which is slope intercept form of a line. And I know most of you have probably seen this in pre-algebra, and we're going to kind of use this quite a bit going forward. So the slope intercept form of a line is what it's called when you have a linear equation written in the form y equals mx plus b, where m is our slope and b is our y-intercept. Now before we go any further, I'm going to back up 2 slides, and you can just watch if you want. Notice this first equation that I had you guys graph. If I asked you to look at the graph, if I asked you to look at the graph and tell me what is the slope of this line, well, you would need to find 2 points on the line and then count up 2, and it goes to the right 1. So our rise over 1 would be a positive 2 over a positive 1, or a slope of 2. And if I asked you to look there and find what the y-intercept was, you would say, oh, the y-intercept crosses here, that's at negative 3. It is not a coincidence that the equation to this line is y equals 2x minus 3. Our slope is 2, and our y-intercept is negative 3. So when you have an equation that's written as y equals some x's plus or minus a number, the number that's multiplied by the x's is our slope. The number that's added or subtracted at the end is our y-intercept. So let's flash forward to that screen we were just on a second ago. When a linear equation is written in the form y equals mx plus b, m is our slope, and b is our y-intercept. So looking at the equation y equals negative 2/3 x plus 5, you should be able to look at this and say, oh, my slope is negative 2/3. My y-intercept is positive 5. So if I want to graph that, looking back at the last question we just did, if I know a point on the graph, and I know its slope, I can start at the point that was given and count my rise over run in either direction to create as many points as I need to. So applying that to this question we're looking at now, I have a y-intercept of positive 5. A y-intercept is nothing more than a point on a graph. So that's this point right here. A slope of negative 2/3. Remember, a negative slope is a negative over a positive, or a positive over a negative. It does not mean that both of the numbers are negative. If you wrote it as a negative over a negative, that would actually have a positive value. So a slope of -2 over +3 means I go down to right 3. From that point, if I go down to right 3, put a dot. Down to right 3, put a dot. Down to right 3, put a dot. If you think of it as a +3 over a -3, +2 over -3, that means we go up 2 and left 3. Again, starting at that first point, I could go up 2, left 3, up 2, left 3. And then all I have to do is connect the dots. Put my point on one close to the edge, line, and drag it through the one on the other edge, and put your arrows. So graphing something that's given to you in slope intercept form should save you tons of time in your graphing. You don't have to plug in 4 values for x. You don't have to get 4 values for y and plot those points. Now all we're going to do is we're going to find that y-intercept and plot that point, and we're going to count the slope up and down, left and right. So let's look at another example here. Y equals 3/4 x minus 6. Looking at this, is it in slope intercept form? Does it say y equals mx plus or minus b? In this case, yes. My slope is 3/4, my y-intercept is -6. So we start with our y-intercept at -6, and a slope of 3/4 would mean up 3, right 4. So we go up 3, right 4, put a dot. Up 3, right 4, put a dot. A positive slope could also be a negative over a negative. That would still give us a positive 3/4. So I could also think of this going down 3, left 4. So from that initial point, if I go down 3, left 4, I can put a dot, and notice that's still on the same line. And then to graph that, we put our arrows at the ends. We'll do one more together, and then I'll have some for you guys to do on your own. So graph this equation, y equals -3/5 x plus 4. Let me show you how quickly you should be able to do these now. I'm going to talk as I go, so it's going to slow me down a little bit, but you should get a general idea of how quickly you should be able to do this. So I know my slope and my y-intercept. I have a y-intercept of 4, so I start at that point. A slope of -3/5, I'm going to go down 3, right 5. So down 3, right 5, put a dot, down 3, right 5, and I'm going to put another dot. I could have also gone up 3, left 5, up 3, left 5, and then draw the line that goes through those points and put your arrows. So again, 15, 20 seconds is about how long it should take you to do this. So right now I'm going to give you a chance. There are 5 questions on this next slide. The first 2 just ask you what is the slope and the y-intercept for each of those equations. And then the next 3 ask you to draw or graph each of those equations just by looking at their slope and their y-intercept. I guess that should be sept. Color each one the colors given. So do the first one in red, the second one in green, the third one in purple. I'll give you a few minutes. Please pause now. All right, hopefully you've had enough time to do this and you've actually done it and not just kept going. Hopefully you've paused and did these questions. But if you look at the next slide, it gives you all the answers anyway. So the slope of the first one is 2, the y-intercept is 6. For number 2, the slope is 3/4, the y-intercept is -1. Graphing these next 3 though, the first one in red, notice it has a y-intercept of 1. It's right there. Has a slope of 1/3. It's positive. Remember, positive slopes go uphill. So when you're finished, do a visual check. If it's a positive slope, make sure it goes uphill. So negative slopes would go downhill. If you have one that has a negative slope, make sure it goes downhill from left to right. This one has a slope of positive 1/3. That means it goes up 1, right 3, up 1, right 3, up 1, right 3, and you connect all those dots. The second one's a little bit trickier. You shouldn't have a problem finding the y-intercept. The y-intercept is 2. But the slope, negative x means negative 1x. So the slope is negative 1. Well, negative 1 isn't written as a fraction, so how do you take any number and make it a fraction? You just put it over 1. So this thing has a slope of negative 1 over 1. So down 1, right 1. Down 1, right 1. Down 1, right 1. Notice it's a downhill slope because it's negative. And then the third one in purple, again, y-intercept is easy to see. It's negative 4. Has a slope of 2, which is 2 over 1. Positive 2 over positive 1, or negative 2 over negative 1. So you either go up and right, or you go down and left. Up 2, right 1, up 2, right 1, up 2, right 1. Or down 2, left 1, down 2, left 1, down 2, left 1. And for all of these, I should have put my arrows at the ends, which I did not. So there you go. What about this next slide? The next slide has an equation 3x plus 2y equals negative 8. And it says to state the slope and the y-intercept, and then graph. Can I look at this equation and know what the slope and the y-intercept are? And the answer to that is no, not yet. In order to know what the slope and the y-intercept are, I have to put it into slope intercept form. Remember, slope intercept form is y equals mx plus b. In other words, I need to take that equation and just solve it for y. Just like last chapter with those literal equations that had more than one variable, and it would say take this equation and solve it for x or solve it for y. For all of these that we're putting in slope intercept form, we're going to solve for y, get y by itself. So to do that, I'm going to subtract the 3x to the other side, and I would get 2y equals negative 3x minus 8. It's a negative 3x and a minus 8. It's still not solved for y. Now I have to divide everything by 2. And that's going to leave me with y equals negative 3/2 x minus 8 over positive 2 minus 4. 8 divided by 2 is 4. So now that I have that equation, I know that my y-intercept is negative 4 and my slope is negative 3/2. So I start at negative 4. And a slope again of negative 3/2 means I go down 3, right 2. So down 3, right 2, down 3, right 2. Or you can make it a positive over a negative, which would be up and left. Up 3, left 2. Up 3, left 2. Up 3, left 2. Up 3, left 2. And then we draw the line that goes through all of those points. So there are these two equations here for you guys to try, one that's given to you in slope intercept form and one that you have to put in slope intercept form. So pause now to do these two questions and then we'll pick back up. All right, so for this first one, we have a y-intercept of negative 7. So we're going to start there. We have a slope of positive 2/3. So that's going to be up 2, right 3, up 2, right 3, up 2, right 3. Or again, down 2, left 3 would work also. And then we draw the line that goes, oops, let's undo that. That didn't take. Draw the line that goes through there. Hopefully you didn't have much trouble with that one. The second one, we need to put it into slope intercept form, so I'm going to subtract the 4x over. That gives me negative 3y equals negative 4x plus 9. And then I have to divide everything by negative 3. When I do that, I'm left with y equals negative divided by negative becomes positive 4/3 x. Positive 9 divided by negative 3 is a negative 3, so I'm going to write that as minus 3. So my y-intercept is at negative 3, and I have a slope of 4/3. Up 4, right 3, up 4, right 3, up 4, right 3. I think I missed that one. 1, 2, 3, that was up 4, right 3. And then we draw the line that goes through all of those points. Hopefully your graph matches that one. We're just about done. Two last questions I want to look at. Y equals 3x. Is that equation in slope-intercept form? Remember, slope-intercept form is y equals, in general, y equals something times x plus something. Does that equation match that? Y equals 3x. Yeah, I have some x's. Y equals 3x. Is there anything added or subtracted at the end here? The answer is no. Well, kind of no. It means we're adding 0. So with an equation that's missing a number added at the end, that just means that your y-intercept is 0, or at the origin. So just a quick sketch of that. I don't want to go through the whole thing. It just means that your y-intercept is 0, and then you would go up 3, right 1 from there. Up 3, right 1, and that would be your line moves through the origin. There we go. Now what about the one at the bottom, y equals negative 3? What's missing from this one is the x term. It's supposed to be some x's plus or minus a number. Well, this one doesn't have an x there, so it's 0 x's. That's like saying y equals 0x minus 3, which tells me that my slope is 0. 0 with a z means it's a horizontal line that goes through the y-axis at negative 3. Or it has a y-intercept of negative 3 and a slope of 0, which is 0 over 1, which means I don't go up or down, I just go right 1, right 1, right 1, which gives me a horizontal line. So if one of those terms is missing on the right-hand side, if you're missing an x, it means that your slope is 0x. If you're missing a number added or subtracted at the end, it means that your y-intercept is 0. Okay. So with that, your homework is go formative 3.4, and we'll answer any questions when I get back to class.